Okay, so let's take a look at the practice problems on page 549. Number 13. A circus stunt person was launched as a human cannonball over a Ferris wheel. His initial velocity is 24.8 meters per second at an angle of 55 degrees. I want to know, how much do you get paid for this? Because you'd have to pay me an awful lot to sign up for this one. So he's launched his VI, 24.8 meters per second, and it tells us the angle is 55 degrees. And it's a ground to ground, so he's going to come back down here. And somewhere in the middle is the Ferris wheel. Where should the safety net be positioned? So you're looking for, in other words, what's delta dx? That's part A. And if the Ferris wheel was placed halfway between the launch position and the safety net, what is the maximum height? So part B, you're looking for delta dy max. And the third part, so this is B, and the third part, how much time passed, but you actually have to find that first before you can find the others. So in the x direction, VIX is going to be VI cos theta. AX is going to be 0. And we're looking for delta dx, and we don't know delta t. In the y direction, and we can get our VIX because we have the 55, the VI and the cos theta. VIY is VI sine theta going up. AY is 9.81 meters per second squared going down. And we don't know anything else. But we can use so the little trick that we will probably always use when it's ground to ground is looking at just the time up and doing AY is equal to VFY minus VIY over delta T. And if it's up, this is a TU, and this goes to 0. And so it becomes delta TU is equal to negative VI sine theta, I know both of those, over AY, which I know. So I can find the time it takes to go up, and then just doubled it will be the full time. So negative 24.8 meters per second times the sine of 55 divided by negative 9.81 meters per second squared. The negative on the 24.8 meters per second is from the equation because it was minus VIY. And the negative on the 9.81 is because it's down and VIY is up. And so when you do this math, you get 2.021 seconds, which means the total time is 4.042 seconds, and this is actually the answer to part C. You just had to find it first. Okay, part A wanted to know where should the safety net be placed. So it's looking for delta dx, and that's VIX delta t, 1/2 AX delta t squared. This goes to 0. So delta dx is equal to VI cos theta, so 24.8 meters per second, cos of 55, times the time you just found, 4.042 seconds. And that will give you a delta dx of 58.914 meters. Okay? Delta dx. And then part B, that was part A. Part B is what is the height of the Ferris wheel? In other words, what's delta dy max? And we know we can get that by doing VIY delta TU plus 1/2 AY delta TU squared, TU time up, because the Ferris wheel is placed exactly in the middle, which occurs at the half time or the time it takes the projectile to go up. So delta dy max will equal VIY is 24.8 meters per second sine of 55 times the half time, which was 2.021 seconds, plus 1/2 negative 9.81 meters per second squared, 2.021 seconds squared. When you do this, your first term is 42.069 meters, and your second term is 21.0345 meters, and so you get a delta dy max of 21.0345 meters. The spots where people usually mess up: they forget the negative on the 9.81, so they end up adding these two terms. They forget to square the time here, or they forget to use the half time. If you've done it right, the second term should be half of the first. If it doesn't work out that way, you screwed up in one of those three spots probably. All right, number 14. Number 14 is a ground-to-ground. You want to shoot a stone with a slingshot and hit a target on the ground 14.6 meters away. So it's going to go up, and it's going to come back down 14.6 meters away. Just double checking it was a 0.6 and not a 0.5. And it tells us that our VI is 12.5 meters per second. And it wants to know what is the theta, what must be the launch angle, and then what would the maximum height reached, and what's the time. Okay, so in the x direction again, VIX will be VI cos theta, AX will be 0, and delta dx will be 14.6 meters. In the y direction, VIY is VI sine theta, AY is 9.81 meters per second squared, and this is down and this is up, so again we need to pay attention to our negatives. And again, because it's a ground-to-ground, start by looking at just the up. So AY is equal to VFY minus VIY over delta T, and if this is up, the VFY is 0. So delta TU will equal negative VI sine theta over AY. The thing is, this time we can't find it because we don't know the theta and we don't know the TU. We can find the full time, though, by taking that and multiplying it by 2. So negative 2 VI sine theta over AY. But I have two unknowns. So I have to go to my x direction and do delta dx is equal to VIX delta t 1/2 ax delta t squared. This last term is 0. So delta dx is equal to VI cos theta delta t. And again, I can't solve this. I have two unknowns. So I have two equations, two unknowns. I'm going to take my equation for delta t and I'm going to sub it in my delta dx one so that it becomes delta dx is equal to VI cos theta, and where delta t is, I'm going to write negative VI sine theta over AY, and I lost the 2. Negative 2 VI sine theta. Okay, so bring the negative in the VI over AY over here. So negative AY delta dx is equal to, and then I'd multiply the VI and the VI together, so VI squared, and then 2 sine theta cos theta. And we're looking for theta, so I could divide both sides by VI squared. Okay, so it disappears over here. And then I'm left with just 2 sine theta cos theta. But there is absolutely no way you could do any kind of anything with your calculator to find this, even though theta is the only unknown. Instead, you have to do the substitution, the double angle substitution that we talked about in the last video. This is going to become sine 2 theta. So you're going to have sine 2 theta is equal to negative AY delta dx over VI squared. Notice I left the 2 here because the 2's in is part of the trig identity. So you need to leave the 2 at the sine theta cos theta. So sine 2 theta is equal to negative 9.81 meters per second squared, 14.6 meters, divide by 12.5 meters per second, and that whole thing gets squared. Then you'll get a sine 2 theta of 0.9166